Yesterday, till what we were doing, is it gauge pressure? What was that we were doing was, did I complete this part? Did I complete? Boys, just
Excuse me,
check,
ma'am.
did I complete this? Can you
Uh,
hear?
yes, ma'am. We
Did
did a
I
numerical yesterday. The
did I do this pressure? Let's start with the variation of pressure with depth. 11B. Steel.
Ma'am, I just started explaining.
Okay, okay, that's it. Boys, no need for the derivation part. You should understand. Your aim is to find, boys, your aim is to
ma'am,
find. Yes,
ma'am. In the previous chapter, we did that graph, right? For
yeah.
I think
Okay.
strain or stress, I'm not sure. Like there was a
Stress was
graph.
stress versus strain graph.
Yes,
Yes.
ma'am.
You
Yeah,
want me
yeah.
to? I'll
No.
upload. I'll upload.
Yeah, you said you'll upload the PPT because we have to write something also.
Okay, okay, okay.
You
I'll do.
said
I'll do.
because you started this chapter, so we didn't write that.
No, 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 no problem. Because writing takes a long time. I'll upload, boys.
Yes, ma'am. You said you'll
Suppose if I,
upload, but you hadn't
yeah,
uploaded. That's
yeah,
why I
yeah, I'll
asked.
do. Just send a message in that group, boys. Then otherwise I'll forget. Send a message in your 11B group. Well, suppose if I want to find the depth at a point A, the pressure at a depth H at point A within the liquid. So inside a liquid, right, the pressure is different at various points. Right? If I want to find what is the pressure at a given point, say at a given point A, which is at a depth of H meter below the surface of the liquid, how to find the pressure at point A. For that, you are considering an imaginary cylinder, which means the point A is lying somewhere over here. Suppose if I consider a cylindrical part of your liquid, an imaginary cylinder, let me consider an imaginary cylinder of the liquid. So now this cylinder has a height h, and both the top surface 1 and the bottom surface 2 both have the same area of cross section. So I'm considering a part of the cylinder, a liquid cylinder of height h, area of cross section A, right? Now, if this cylinder has to be in equilibrium, if the cylinder should not topple, it should be in equilibrium, you see, all the forces acting on the cylinder must be equal to 0. The along the sides, the forces which are acting along the sides of the cylinder are equal in magnitude but opposite in direction. So all the forces acting on the sides of the cylinder cancels off. Only the forces which are now acting is either vertically downward or vertically upward. So now the sideways forces are balanced. Now let us see what is the forces which are acting downward. The force which is acting in the downward direction will take it negative. The forces which are acting in the upward direction will take it positive. So what is the force which is acting in the upward direction? F2, right? Plus, which must be equal to the forces, total force acting in the downward direction, F1 plus M into G. So if the cylinder has to be in balanced condition, the total upward force must be equal to total downward force, or in other words I can say F2 minus F1 must be equal to M into G. So what is F2? It is the force acting at the bottom surface of the cylinder. F1 is the force acting on the top surface of the cylinder. Now you know that pressure is equal to force by area, or force is equal to pressure into area. So now F2 becomes equal to the pressure acting on the bottom surface is P2, area of cross section is A. Similarly, the force which is acting on the top surface, the pressure is P1, area is A. Pressure is force by area, or force is equal to pressure into area. So which is equal to M into G. So which is your common factor here, boys? Area is your common factor. So P2 minus P1 into A is equal to M into G. Or I'll bring area to the other side. P2 minus P1 is equal to M into G by your area. So what is mass? Mass is what is density? Density is mass by volume. So mass becomes density into volume. So your mass is density rho into volume. So I can write rho V G by A. Should I
Ma'am,
go
this
stepwise?
should
Should I
this
go
be
stepwise? Should I go stepwise once again, erasing and making you to you write along with me? Then it's better because you better write along with me. Just write along. I'll take a new slide and I'll go for it. You start writing. Right. Net upward force. Net upward force. This is all acting on the cylinder. Right along. Acting on the cylinder.
Ma'am, this derivation is not there, right?
It's not there, it's only for you to understand, boys. Just keep writing. That's what I'm not making you to write the entire thing. You can first draw the diagram, just write net upward force acting on the cylinder. What are the upward force acting on the cylinder? It is F2. It will be F2 plus M into G. So upward force is F2. Net downward force. So what is the net downward force? Net downward force is F1 plus M into G. For the cylinder to be in equilibrium, for cylinder, the liquid cylinder to be in equilibrium, F2 must be equal to F1 plus M into G. So F2 minus F1 is equal to M into G. Now how will I write? Since
Write it as P.
pressure, okay, pressure is equal to F by A, general formula, right? What is force? Force is equal to P into A. So I can write this as equation 1. Therefore, equation 1 becomes, so F2 can be written as P2 into A because area will be the same. P1 into A is equal to M into G. So P2 minus P1 into A is equal to M into G. Or P2 minus P1 is equal to mg divided by A. Now I have to write P2 minus P1. Mass, I can write it as density into volume. Mass is equal to density into volume into G divided by A. Okay. Now you very well know, since again I'm writing was since volume is equal to area into height, so volume by area will be equal to H. So therefore P2 minus P1 becomes equal to density. I'll put density as rho. Rho is the density of the liquid. Volume by area is H. So P2 minus P1, the difference in pressure is equal to H rho G. Have you completed, boys?
No, ma'am, 1 minute.
Okay. Shall I go for the next one?
Ma'am, here rho is the density of the
Density
cylinder,
of the
ma'am,
liquid.
of the
It's not
liquid.
the cylinder is liquid cylinder. The cylinder itself a liquid cylinder. You are considering the liquid in the form of a cylinder.
Okay, ma'am.
Okay. Shall I go for the next slide, boys?
Yes, ma'am.
Okay. Now look at this, boys. So this is what you have arrived at. You've got this, right? Now what we'll do is that we'll push the cylinder to the upper surface. Suppose if I put the cylinder, previously the cylinder was below, right? Now I'll put the cylinder so that the surface 1 is exposed to atmosphere. No need to write the statement, only the diagram. You can have a rough diagram. Your cylinder has now moved to the upper surface so that the upper surface is exposed to your atmosphere. So let the pressure on the top surface be equal to P1, which is equal to now atmospheric pressure. The pressure at the lower surface P2, we'll write it as P. Right, boss? Now what happens to this equation? P2 now becomes equal to P. P1 now becomes equal to atmospheric pressure. So that is equal to rho G H. Then what is P? So what is P? P is what is P? P is the pressure at the depth of H meter, boys, because P is the pressure acting on surface 2. Your surface 2 is at a height of H below the surface of water. Are you clear, boys? Are you clear? See, what is P? P is the pressure which is acting on the bottom surface of the liquid cylinder. And this bottom surface is at a height h below the liquid surface in the beaker. So P represents the pressure at a given height, at a given depth. Right? So P becomes equal to PA plus rho GH. What is P? P is the pressure, and we call P is the pressure at a depth h below the surface of the liquid, which is exposed to your atmosphere. So P is equal to PA plus rho GH. So the pressure at any point which is at a depth of h meters below the surface is rho A plus rho GH, and P minus PA, we call it as gauge pressure. P minus PA, we call it as a gauge pressure. P is called the absolute pressure at a given depth. P is the absolute pressure at a given depth. The statement is not required. Only the diagram you need. You're taking the liquid cylinder to the top surface so that the upper surface is exposed to atmosphere, so that the pressure at the lower bottom surface, which is at a depth of h meter, is given by P is equal to PA plus rho GH. That is what we call it as absolute pressure, or the pressure at a given depth. P minus PA is called the gauge pressure. Only these two things you should remember, boss. So at any given depth in a liquid, the pressure is given by the formula P is equal, if it is exposed to atmosphere, P is equal to PA plus rho GH.
Gauge pressure is when atmospheric pressure is 0, right?
Gauge, which one?
Gauge pressure.
No. Gauge pressure is when the top surface is exposed to atmosphere, the difference in pressure, the excess of pressure at a given depth is called the gauge pressure.
This one.
There is no derivation as such you have to learn. You should know what is your absolute pressure. You should know what is your gauge pressure. Shall we
Ma'am,
move to the next one?
do we need to write
No,
any of
no,
the
no,
okay.
no statement at all, boys. It's all there in your textbook. It's only the preliminary part you are learning. That's it. You should know which is gauge pressure. You should know what is absolute pressure. That's it.
Ma'am, PA is always one, yeah?
PA is atmospheric pressure.
Oh,
Boys, have you completed? Because I have to start Bernoulli's theorem, but I think it takes time.
We're done.
Anyway, now to measure your atmospheric pressure, we use what we call it as a barometer. This is the basic barometer, Toxelis barometer. Uh, this is all the basic information, boys. Now we'll go for manometers. Manometers are one which are used to measure the pressure enclosed pressure of the gases in enclosed gases. Can you see this? If you have, if you want to find the pressure of the gas which is being enclosed in a round bottom flask, now you use your manometer. Now you can see your manometer is nothing but a U tube which consists of a liquid. Generally, we use mercury as your liquid. So if I want to find the pressure of the gas inside a chamber, now the the gaseous enclosure should be connected to a manometer. Your manometer basically consists of a glass tube. It will be graduated glass tube. You have graduations on both the limbs and it is filled with mercury. Basically, we take mercury as the liquid in your manometer. So what happens is that when you connect it to a gaseous chamber, the gas will exert a pressure. You can see here, the gas will exert a pressure. Since the pressure is being exerted on one column of the liquid mercury or the liquid will rise up in the other column. So the difference in height was the, suppose if I have you learned about U tube in your lower grade manometer tube? Have you learned this 8th grade, 11th standard?
ma'am, I think we have seen it somewhere, like in the textbook itself.
Fine, boys. Manometer, generally, basically, a manometer is a U tube. Now, both the limbs will be of the same thickness, boys. My diagram is both the limbs, it's a U tube, right? Both the limbs will have the same area of cross section, right? Same area of cross section. Now it's filled with, generally we use mercury as your liquid. So it's filled with mercury. And sometimes we go for some other liquids also, but generally it's mercury. Now look at this. These both ends of the limbs are exposed to your atmosphere, right? So in that case, what is going to happen is the liquid in both the limbs will be at the same level, right? The liquid in both the limbs will be at the same, the liquid level in both the limbs will be at the same level. Now, when this manometer is connected to a chamber which consists of a gas, now what happens? The gas will exert a pressure on one of the liquid columns. Suppose this is connected, this end is connected to a gaseous chamber. Now, the gas will exert a pressure on this column of the liquid. So then what happens? This column goes down, the other column of liquid will rise up. So there will be a difference in height of the liquid columns in both the limbs, and this height plus into the density of the liquid gives you the pressure of the gas enclosed. So manometer tube generally are used to find the pressure of the gaseous substance enclosed in a chamber. Now we'll see how to find. Now look at this, boys. So you have a gas enclosed in a chamber. Let P be the pressure of the gas. Now it is connected to a manometer tube. Now what happens is that the pressure of the gas, so the gas exerts a pressure, and so that the liquid will rise up in the other end. Now when the liquid, one more thing you should always understand, in case of a static liquid means the liquid is not in motion. If the liquid is not in motion, suppose I take a horizontal line. Now, at point A and at point B along the same line, the pressure of the gas will be the same. Boys, understand this. If I take a liquid in a beaker or a container, then at points which are lying along the same horizontal plane will be at the same pressure. Now, your aim is to find the pressure of the gas enclosed in the cylinder, which means, can you see these 2 points, boys? Point A and point B. Now, these 2 points are at the same level. These 2 points are at the same level. Hence, the pressure at point A must be equal to the pressure at point B. Is that clear? 11B, 11th standard.
Ma'am, but A is experiencing pressure from the gas also, right?
Yeah, that's what. That is how you have to find. So point A experiences pressure from the gas. Pressure from the gas. So let the pressure exerted by the gas be equal to P. So P becomes equal to PA. P is what? The pressure exerted by the gas on the liquid at point A. Is that clear, boys? P is the pressure exerted by the gas enclosed on the liquid at point A. But when you see the manometer tube, you also know that PA is equal to PB. If I can find the value of PB, the pressure at point B, that will be equal to the pressure at point A, that will be equal to the pressure exerted by the gas. Now, what is the pressure acting at point B? Now, look at this, boys. The pressure at point B, atmospheric pressure, yes. It will be atmospheric pressure, yes, correct. It will be atmospheric pressure plus the pressure exerted by this liquid column of height h. Are you clear, boys? The pressure at point B has 2 components. One is the pressure exerted by the atmosphere. The atmosphere is exerting a pressure, plus there is a liquid column above the point B, which is of height h, right? So a liquid column of height h exerts a pressure at point B in addition to your atmospheric pressure. So the pressure at point B will be equal to the atmospheric pressure plus the pressure exerted by the liquid column of height h. What is that? H rho g. So now you equate PA is equal to PB, which is equal to PA plus H rho g. Therefore, the pressure of the gas, which is equal to PA, will be equal to PA plus H rho g. This is how you measure the pressure of the gas enclosed in any cylinder. Should I repeat 11B? Joshua? 11th standard?
Ma'am, can you just show the previous slide, please?
Boss, do you understand? 11th standard, do you understand?
Yes, ma'am, we do. Yeah.
Boys, numerical last period will go for the numerical. So what
Ma'am,
will you
could
go
you show
for
the
this?
previous slide, please? The slide we were discussing. Yeah, ma'am. No. Yeah, ma'am.
was PB, PA, okay, pressure exerted, so pressure exerted by the gas P is equal to PA. So you have got the value. If you want to find P, you have to find PA. To find PA, you have to find the value of PB, right? So the pressure exerted by the gas will be equal to PA plus H rho G. Next, we'll go for, now comes the real chapter, boys. So far, apart from Pascal's law, whatever you have learned, the pressure is at a given depth, gauge pressure, absolute pressure, then manometer tubes, these are all for your ideas. While solving numerical, you can use as a whole. The theory will not be tested as a whole, apart from Pascal's law. Now comes the theoretical part, what we call it as streamline and turbulent flow, right, boys? The liquid, you have seen liquid flowing in pipelines. Now the flow of a liquid can be classified as a streamline flow or a turbulent flow. Okay. Just you copy this. Flow or make it as
Ma'am,
classified. Yes, boss.
ma'am, should we write the whole thing?
No, you just this also I'll put the PowerPoint
Okay,
presentation. Just only this
so
much.
what do we
can do,
write
boys.
in the
No, I
notebook?
will explain. I'll explain to you flow of a liquid, streamline, and at least this much you can write: turbulent, streamline, and turbulent. Flow of a liquid, streamline and turbulent. We'll see what do you mean by streamline flow, what is meant by turbulent flow. Is that clear, boys? Just only this much you copy: flow of a liquid, streamline and turbulent. The next class, we'll see what is streamline, what is turbulent. You need not write right now because I'll put this PPT. The theoretical part you can learn later. You can copy down later. So next, last period, I have to do equation of continuity and I'll start with Bernoulli's theorem. Because only this much, that classification you do was.
Ma'am, we can leave, yeah?
You can leave, you can leave.
Thank you.
Thank you,
ma'am.
ma'am.
Thank you.